Well, thank you everyone for attending. My name is Rick Stewart. I'm a middleware and OpenShift solution sales professional at DLT Solutions. My colleague and I, Mike Fitzurka, AKA Mike, AKA Fitz, AKA Michael, will be presenting today an IoT solution, one pattern that could be used in an IoT solution that helps you manage your messages better and process data in a more effective manner. It actually is a live demonstration. We are breaking every rule to have this live. It's not canned, it's not PowerPoint. But first off, we're going to go to the next slide, Fitz, please. We're going to go through some basics. Don't want to insult anybody's intelligence with the Internet of Things. What is it? But there's a lot of different definitions that you hear around the industry about the Internet of Things. And my definition, it's a thing on the Internet. Just kidding. It's basically a series of devices that are connected to the Internet that produce data or sense data to be processed. That can manifest itself in many different ways in terms of being biomedical, sensor data, radiation sensors, etc. How they manifest themselves in the Internet of Things could be as simple as finding a parking space system. That system would detect that a space is empty or it's filled with an automobile or a motorcycle, and it would send that information back to a data center to be processed. That information could be propagated out to mobile applications to help drivers find the next available parking space, or as simple as you'll see in malls, they have green and red lights on there to show when spaces are available so you can see them in distance. That's a simple solution with an IoT architecture. Also, sensors and medical devices are high use of Internet of Things, more serious in terms of time to action, in terms of monitoring blood pressure, vital signs of a human being, and taking the appropriate action, whether it be dosing, medicine dosing, or getting a nurse or a doctor to look at the particular threshold that was surpassed. Then you get into a more robust Internet of Things where you have oil rigs that are sensor filled and more mission critical in terms of time to action, and you have lots of things to monitor and put sensors on, whether it be the oil pressure, the drill pressure, the current in the water. These are life-threatening issues if they become too detrimental. These sensors become too detrimental. You have to take action or people die. Lots of people die. And then you also have the ability, and doesn't show well here, all the way up into a smart city where you have power grids, sewer plants, everything within a city that is automated or sensed to help that particular city's citizen go about their lives in a more useful manner. Next slide, sorry. So we have a typical architecture where you have these, let's call them just sensors for now in order to be simplistic, that are sending data to a data center to be processed. A typical, and these are real life scenarios where project leaders and architects are given projects to do Internet of Things type applications. And what they typically do is just connect those devices to their data center in order to retrieve the message to do the processing. Hit next screen, please. And what happens is, and the speed is not good, these messages, even though they're small, compact, they could generate messages on the hundreds, thousands, tens of thousands per second, depending on the type of device and the number of devices in your system. And what happens is you end up using your bandwidth, even though these are small messages, and from a 100,000 foot view, it doesn't look detrimental, but when you aggregate them across many different devices, those messages will clog up your network and cause latency. Next one. Now, there's plenty of messaging solutions that you can implement in order to handle those types of volumes of messages But even if you do, the types of the quality of message that you're getting may not be a useful message, and you're just going to end up using all of your storage and your resources within your data center that may be better used in more of an aggregate situation or more meaningful data being processed. So,
Sorry.
enter the edge computing. And edge computing, the term just comes from moving more processing capability out into the edge of your system to your devices so they can be processed in a much faster and much more intelligent manner. A typical gateway would have some kind of messaging infrastructure, again, in order to handle the volume, whether it's deployed in a local environment or it's across regions. You can handle not only the volume of message, but a myriad of different protocols that you can support. And also, you would want to abstract some of your rules that you have in there in order to not have to deploy these gateways over and over again with new versions. You can handle its processing of those messages at a more layman's terms by using rules in order to process those messages more effectively. Next. So in this scenario, you still get lots of messages coming into your gateway, processing them accordingly, but using your rules, you could filter those messages out to be more meaningful to send back to your data center in order for processing or storage or action upon them. Next one, please. And a gateway, if it's intelligent, should be bidirectional. Have the ability, whether it's a gateway that is smart and can react and can actually process something on the device themselves, either instruct the device to cool itself down, instruct the device to boot itself, etc. It should have the ability to send that way. Or you can have a messaging infrastructure that ensures that it goes back to the data center, which it has rules in order to do smart processing at the data center level. And if that processing manifests itself in an action back to the device, it can get to that specific device. What we're going to do here now is demonstrate this is an actual series of technologies that Mike Fitzurka put together that takes sensors that detect temperature and humidity, and we have hooked it up to a Raspberry Pi as a smart gateway, and we're using his laptop as a data center. And I'm going to turn it over to Mike to be a little bit more detail-oriented in terms of the technology.
Sure, thank you. So, yeah, as you were mentioning, I built sensors this is just a micro sensor or microchip with Wi-Fi capability and a temperature and humidity. I'm going to try to double go through things here. Great. So this is a bit of what the sensor is. You have the microchip, a temperature humidity sensor. There is a light on the item itself, but I added a light just so that you can see it a little better and up front here. Hopefully it's not too bright. As we said, so that's our sensor, and we've got 3 of them. We've got 2 over there and 1 here. The gateway is a Raspberry Pi that's just hooked up to a portable power supply. And that has Docker with 2 containers. The first one being Fuse, that's messaging, so it's going to receive the message. It's going to enhance it a little bit. It's going to the sensor itself is very dumb. It just spits out, this is the temperature. This is the temperature, and it does it every second. The gateway is going to receive that, add date time to the stamp, and move it to the rules engine. The rules engine is going to say, if the temperature hasn't changed, I'm not going to tell the data center. Right? It's the same as it was last time. Because it's not sending data every time, the average is calculated on the gateway because you wouldn't be able to accurately calculate the average without all the data points. So some of that information is calculated and then sent to the data center, which is, as I was saying, a VM I have here on the laptop, which is shut down by now, so let me put in the password. Bring this over. So,
Is anybody familiar with the Fuse console from Red Hat? Fuse is a very lightweight, very adaptable messaging infrastructure that can adapt to various different protocols and send messages. And it actually sits on top of ActiveMQ, which can do all of your queuing for messages for persistent storage or asynchronous storage.
so this first queue is on the Raspberry Pi itself, and then the second queue is what your data center, and you'll see more information flow in when I power up the sensors. And then it gets sent to a business process management as another container on the data center that will then allow, okay, so there's an alert, the temperatures, it receives the information in another fuse. It then has another rules engine. This time it determines, well, is this temperature too high or too low? Should I do something about it? If it triggers, then it sends it to a third container on the data center, which then starts a human process in order to process the actual event itself. So create a workflow, allow people to go and check out the sensor and what's wrong. So if that's, let me try to then plug everything in, if you could hold that.
Yep.
So, two sensors here, and I put the battery sensor here so it's more portable. All right, I'll put that up front here. Now what we should see is that you can now see that, thank you. You can now see that messages are pouring into the data center 3 at a time, 3 every second. So we're already up to 50. And if you look at the same queue over here, we've only received 5 because the temperature from the sensors have only changed 5 times. All right, so to simulate a too hot scenario, if you've ever put your computer in your laptop, or your laptop in your lap rather, you'll know that this is really hot. So I can show you on the Raspberry Pi the information as it's coming in. Bring that over as well. So every time that the XML is printed on this log is when the temperature is actually changing. And the rules engine is set right now that if it goes over 30 degrees Celsius, the alarm will go off and say it's too hot. So we should be approaching that soon. Move you a little closer. And payload's 28. This is blocking the. Did it get lower?
Live demos, you love them.
Live demo. Well, I know it's going up temperature 28, 29.
There we go. Next
You
one.
can do it. That's the other one. 30. One more and the light should come on. Come on. 31. And the
Yeah.
light's on. So hopefully you can see that. Okay, I'm going to move it away because I don't want it to burn out too much. But this has now triggered an event. So let me move the Pi away. And log in. Oh, let's fuse. Okay, so.
This is Fuse on the data center.
Okay, so this is the fuse on the data center, and we've now collected 400 hits. The data center's only had 40, and that's only because I've been sending more with that. But on the processing now, you will see that a human task has come up to handle this event.
Give me 1 second, Mike. I'll talk
Sure.
about BPM Suite. Are you familiar with that? Anyone in the audience? It's basically a workflow or a business process management tool that allows you to capture your workflows, whether they be automated or even human task oriented in order to simulate real life scenarios or external calls out to systems in order to move your process along. So we have built that into this particular demo.
Okay.
And
Thank
I
you.
use
Yeah.
we very lightly. Mike did it.
Thank you. So here's the work event. Actually, I will say this. When I started the process of building this demo, I was looking out in open source, and of course someone had already done this. So I should give recommendation or a shout out to attribution to Patrick Steiner, who did a lot of the work on this. I did modify some of the code to apply to this and helped contribute to his open source project as well. But it did come from open source. So you can set in the details. All right, yellow sensor. Hot. You would then bigger screen, update that. Okay, great. Someone would then get an issue, like you could send out an email to someone. Actually, this was originally built and it was sending emails out to Patrick Steiner in Germany for saying my sensor was too hot. Then you could go in, someone could go out and said, moved away, so it's good now. Add that comment. Person back in the main office would say, okay, I see that you've commented, great, let me complete this. And if everything goes well, the information will then travel back through the gateway to the sensor to turn the light off and say the alert is no longer valid.
And not affecting the other devices.
Yeah.
It's just a message right to that one.
It's to each device, and it's off. So live demo. So that's the demo of it, but the concept is I'm not trying to sell temperature monitoring. There are other solutions for that, but the fact that you can move the processing of your data that is coming in to an external or several external sources and scale up that way. It's sometimes called fog computing because it's cloud that's come down to the ground, but it allows that processing to be offloaded so you're not overloading your main data center. And you're not also sending so much information for all your communication costs of traffic and network traffic.
Right. And it's also called distributed computing. So,
Well, it's got lots of names.
but with the Internet of Things and as devices become more prevalent, ubiquitous across the world, this kind of pattern could be repeated, and the applications and implications are, myriad, infinite number of applications. So we are done with the demo. As Mike said, this is open source software that Patrick Steiner contributed that Mike forked. But Mike has made this available in a public manner.
It's on GitHub.
It's on GitHub. The address was it Michael Fitzurka? GitHub. You can certainly go out there and fork it and contribute yourself. And if you want to build and play around with this technology, it's out there and it works. And incidentally, the gateway processors or the products that are running on that Pi are extremely lightweight. I mean, that Pi doesn't handle a whole lot, and the amount of messages and a lot of processing and a lot of rules that you can generate on the Pi via the JBoss products is significant. And
Any questions?
We'll take questions. I knew you had one.
Well, how much resources do you have on that Pi right now?
Okay.
It is for a $35 card, it is surprisingly robust, but it is finite number of resources. There's a card that you put into it, a micro SD, that's at best 32 gig that it operates on, so it's not a lot of disk space, but it is a quad-core processor. It's probably the equivalent of the top of the line 10 years ago, but it for $35, not too bad. So, and again, the point, probably you wouldn't want to put a Pi out in the field, but just that it is lightweight, it can run anywhere.
And he can take it to trade shows and shows like this, so,
Exactly.
without a case. But gentleman in the back, you had a question?
Yeah, so the messaging between the IoTs and the gateway, are they synchronous messaging or are they request response?
Asynchronous question.
Well, they're asynchronous. I mean, you could build it synchronously, but so it's really immaterial. But the messages definitely coming from the card are just sending a blip. I'm this temperature. All of the other messages, they were built for this to be asynchronous.
And how does it know to track that? How does the gateway know to track that?
Good.
So the gateway then sends a message just to another queue that the chip is pulling and saying, oh, I've got a new message and let me handle it. And it's a simple light command, turn on or turn off.
So are the devices, do they have standards in place for these methods?
The devices themselves do not. I suggest using standards? Yes. So we built this on standards, MQTT messaging, and of course all the Red Hat products that are built on standards as well. But that's not enforced by the devices. That's just enforced by me or whoever the developer is.
Actually, it just reminded me of a significant feature of having these smart gateways or these edge computing. These devices, again, are relatively dumb. They send out messages. In order for your data center to be secure, you would probably want to have any kind of APIs having certificates or some kind of secured exchanges. With these gateways, since they can do more, you can run EAP, Fuse, et cetera. These can handle certificates. They can handle more security-based protocols. So you would want to have those in the field fronting these dumb devices because you wouldn't want to expose yourself to man-in-the-middle attacks or any kind of security vulnerabilities.
Anything
And with
else?
that?
Well, thank you very much.